everyone, my name is Brian and I'm the 3D print creator. This is not an episode or something, this is a live stream of what my printer is printing, and this is meant for the Facebook group 3D printing, where there is a contest, and in this contest it's all about printing a self-made Nerf dart compatible launcher. And Nerf darts, well, those are those nice little darts as you can see here. And you have to create a Nerf dart compatible launcher, and at this moment my printer is going to make me one. It's from several parts, there are a lot of parts I have to print, and I have already a lot of parts printed yet. And for example, this what I have here is some part of it, and this is only half of the frame, so the other half of the frame has to be printed, and well, my printer is going to do so in a few minutes. As it starts up, it will start printing it. The purpose of this live stream is not that I'm going to talk a lot about it. In fact, it's late at night here in Holland. It's 12 o'clock in the night. So I will be, I think, for about an hour attending this stream. But I do have to go for a walk with my dog. So what I'm going to do, I'm going to show the stream. And as there are a few people watching, maybe I will come back and tell a little bit about what I've made, how I've created my Nerf dart compatible launcher and how I've done that. But in fact it's going to be mostly the stream that you will see, and it's coming from the camera that is mounted inside of my printer, which is here. And this camera is going to be the camera we are going to watch the most. So this will be it for a big part of the stream. So this is what is happening right now. This print will take about 8 hours and 37 minutes. And I don't think a lot of people are going to watch the stream that long, and I won't even be streaming for that long, I'm sure. I will be coming back in, I think, about 15 minutes from now, and then I will talk a little about how I created this gun which I'm making. So I will see you back in about 10 to 15 minutes from now. See you so long. So there is the audio again, and there is me again. Hi everyone. So I'm here, I'm back from my walk with the dog, and I saw some people are already asking what am I printing? Well, it's a Nerf gun from the 3D printing Facebook group. There is a contest going on there, and actually what I'm printing right now, I'll show you on the rear camera screen. Here you can see it. What I'm printing right now is the other part for this, because this is only half the part, and I'm printing the other part for this. So I took a normal air gun, because those are the only guns allowed here in my country where I live, in the Netherlands. And I took the measurements of this air gun, and I used those measurements to create my own trigger assembly. So here this is based on the air gun I'm having. And well, what's on my print bed right now, which is printing there, that's the other half of this part. And I will get for you some other parts, so I can give a sneak peek in what I am doing. Take a little while. Take a little time to get all the parts. And there I am. Take the full screen monitor here. So basically what I've designed is a full-scale gun. And this is the back part, the shoulder part, where this has to be mounted to. Then there is this trigger, which is only half, because the other half I'm printing right now. Then in front of the trigger part there is this thing, and in front of that there is another assembly which I have to print, which I haven't right now at this moment, but that will be printed tomorrow, because all the files are now created. this contest where you can enter to create a Nerf shooting apparatus. And there are a lot of nice prizes that can be won. So, well, a lot of people are attending this group, and a lot of people are printing very nice things. Well, here is something I haven't seen yet. Here's my teaser on my last round of design tweaks. Well, it's something who is going to make a fancy display in his gun, I think. Well, a lot of nice things. So, a lot of people are printing nice things. And I am trying as well. So take a look at my printer again. Here it is. And by the way, how do you guys like how I made the display of my printer visible inside the screen? I can also do it with my own face here. And of course, I have to say, I'll show it. So here it is. So I just today bought a new webcam, which is a very simple webcam. I bought it second-hand for only €5. It's really incredibly cheap. And it was brand new. It was a second-hand thing, but it was never opened. So it was a complete new in-the-box thing, and I had to remove all the plastics from it and a brand new webcam for only €5, which is pretty cheap. And here I see, is anybody else having audio with tons of reverb and echo? Hey, so there is an echo and reverb on my audio, I hear you guys say. Well, I can check, of course. And indeed, the audio is very, very strange. And I don't know what the reason is. Take a look at why this echo is. So I'm going to try and reset it. The screen won't stop. I'm going to try and reset everything, and we'll see if that helps. Take a look, and see if the audio is better now. I hope it is. Take a look, and see if the audio is better now. Okay, so when I have this screen on, the audio is better. So there is something, and I don't know what. When I change to the other monitor, I think, or to the other camera, I think. So I'm doing this just as a simple test to see if the audio is still good. Or to the other camera, I think. So doing this just as a simple test, and I can hear my audio as well. And so we have the possibility to take a look at my printer, and I think only in the multiple screens some things are going wrong. So here the audio is better. Thank you for your feedback, Beard Kula. And I don't know who else are here at this moment. I saw that the 3D printing kit was here, and Stein Carlsberg was here, and Printer Ting, hey! Nice of you to join. Printer Thing is here as well. And I always try to follow his stream, but he lives on the other side of the planet. So when he's awake, I'm sleeping, and when I'm awake, he's sleeping. So now we meet each other here on the live stream, and it's great. I like that. But the thing is, well, I am trying to make this gun, and because there are a lot of people attending, I really don't know what to expect. But I've tried a whole lot of other principles of shooting a Nerf dart. And this is what I want to talk about with you. Because it's really a challenging contest. And I'm going to show you guys why. So I have to grab some other things as well. And here we have it. So my very first design I made was a design in which I could pop a Nerf inside a small barrel, and I was looking for a real small barrel here because I thought, well, if the barrel is small, then there is not so much resistance. And then I wanted to have something that shoots it inside here in this second barrel. And then when this part goes with a lot of speed until the end, and it stops immediately, then at the front the Nerf has to come out. So that was my thought. But a Nerf weighs less than a gram. And because it weighs less than a gram, it's very difficult. And I'll tell you why. Because if you're having the whole Nerf inside of a barrel and you are shooting it out of that barrel, the moment this barrel stops in its rapid movement, then the Nerf has to fly along. And when it tries, there is a lot of resistance here, and this resistance is big enough to dramatically slow down this Nerf. So this wasn't a good way to go. And then I said, well, let's make it propelled. So I said, if I can blow something behind the Nerf, like I do when I use my mouth to blow in this hole and blow it out, then you see that the Nerf comes out, and this goes pretty good. This was a very soft blow, but it can shoot very hard. So I was thinking, if a gas cylinder can blow out that Nerf, then it can be a very hard shot, and I can blow this Nerf far away. So I tried, and here I have a gas gun, and this gun uses those gas cylinders, and with a gas cylinder you can shoot, yeah, it's a normal air gun. So there is gas inside here, and there is no live ammunition inside here. So when you shoot it, then this gas is going to shoot out. And I tried on a Nerf dart, but you will completely destroy your Nerf dart. There is so much force from that gas cylinder that the Nerf dart is completely destroyed. And this wasn't the way to go. So I tried another way, but first we take a small look at the printer again. Still going okay? Yeah, still going okay. And so I come back to this screen. Then I was thinking, maybe I could make something like this. This is based on the principle of a shooting pen. And a shooting pen, well, there are some real shooting pens which use live ammunition, but this isn't, of course. For a shooting pen you need something to move that Nerf from the pen. So I was thinking, well, if I have a spring load, like this, then I could move that Nerf and I could shoot it from this pen. But how do I keep this spring in its energetic state, so there is force behind it? And then I was thinking, well, I could make this small hole here, so I can put something inside like this. And for you guys to know, this is only 2 millimeters big, and this is all printed. So I've printed this thing, and this hole here is also 2 millimeters in thickness. So this can be put inside, and it can be used to unlock a hole that you can see here. There is a small hole there, and with that small hole there could be a spring load which could be retracted, and that was my basic idea, but I'll show you guys why it won't work. I have to get my knife here to get this thing out. First of all, I really have to get it out like this. First of all, I wanted a spring inside this hole. So I was thinking, well, if I can put the spring inside that hole, then this can be pushed back again. So every time you have the spring which goes on top here, and you're going to lock it in its place, then this will be pushed back, and this spring will only be released when I push the button. That was my basic idea. And in fact it works if you make it bigger, but this is so small that there has to be a hole here. I hope you can see it. And in this hole there has to be a side arm, and that side arm has to come out here to mount the spring against. So it had to be built with only 0.5 millimeter thick plastic, and that plastic wasn't strong enough to hold the spring. So I stepped off that idea as well. Then I've been playing with the idea of a barrel like this, and then use that barrel with special springs like this spring here. And the basic idea of it was that if I have it like this, it would be inside this holder, and it could be like what I have here, that force is applied like this and shot away. And there is enough energy from this spring to shoot the Nerf dart away. So I was thinking, well, this is a nice thing to do, but the problem is that you have to make something that holds the energy here until you really pull the trigger. And this was pretty difficult to do. So I also stepped away from this design. And that made me bring up this design. And I have to get it in front of me. Here it is. In this design, I've done things a little bit different. Here is the compartment where motors will be made. And only one motor, in fact. And that one motor that will be on this mount, or it will be under this mount. And then two wheels will spin. One wheel will spin clockwise and the other wheel will spin counterclockwise. And then when a Nerf is brought in between, the Nerf will shoot out because the two wheels grab the Nerf from its sides. So this is now the idea I'm working with, but then you need, of course, a motor, which isn't a big problem. I have a lot of motors here. Also, because you want those two to have the exact same amount of rotations. So in the back side, and that is where this comes in, on one part there will be a motor, on the other part there will be a gear assembly, and that gear assembly will be connected to the motor from one side and to the ring here on the other side, and that makes that they both turn in the same speed, and then they will shoot out the Nerf. But it had to be appealing, and to make it appealing I wanted to make a barrel, and on top of that barrel I wanted to make, it's not really a silencer but a flash hider. Of course there is no flash, but I thought, well, it might be funny to have a flash hider. And well, it looks something like this when it's mounted. So this way I can make something nice that shoots the Nerf, which goes all the way through like this, and it comes out from the barrel. And now the resistance is so little that it will go easy through. And I already made a movie, and you can find it on my channel here, on how to sand your barrel from the inside, because it has to be really smooth. And I made a movie on that as well, so you can see how to sand a barrel. So this is basically the way I am going to build this Nerf gun. And then there was one more special thing I'd like from this gun, and that was on the front of the gun. I'll bring it up here and I'll show you. On the front of the gun you see this this piece I've here, and I'll make it more visible for you guys when I do it like this. Here you can see this front piece, and here this is an opening, and you can mount something in that opening. And you can also see that there are two screw holes where you can mount rods that connect all the pieces together. But in this opening I have the possibility to enter a GoPro. So when you are shooting someone and you're working with this Nerf dart gun, then you can see actually if you hit someone, because the GoPro films everything. And I think this is a funny design. I hope you agree with me. So yeah, I think it's very nice. I'm going to read the comments here, and I see make a tiny rail to mount optics and accessories. Well, yes, I'm going to make that. As you can see here on the gun, and before I can show that I have to make it transparent again, like this. So. As you can see here on top there is a large opening, and this opening is here because I need batteries. I have to show it, I didn't show it, sorry. So here we are. There is an opening, and I have to see how I can move it around. Here you can see there is an opening here, and well, this is a funny long rail here, and on top of that there will be a battery holder, and that battery holder that holds D batteries. We call, I don't know if they're all called D batteries in the whole world, but in Holland we call them D batteries. Those are those thick 1.5 volt batteries, and I can mount 5 in line, so I have 7.5 volts. And that will be enough to power a laser, hint. That will be enough to power an Arduino, and with that Arduino I can have some things which I'm not going to tell right now, but it will be included. And well, yeah, it gives me the possibility to power the motors as well. So and on top of that there will be a rail that's Picatinny compatible. So you can mount optics and that kind of things on it. But you can also mount a monitor on top of it, because you have that GoPro in front. And you can make it work with a GoPro. and I see the 3D printing kit. Hi as well. And Jeremy Lazun, very clever design. Well, thank you. Thanks a lot. You could always ask Jerk Spray from the Slingshot channel. Yeah, yeah, for sure. He has a lot of nice slingshot, but then it won't be my design. And one of the rules in this contest is that you create the gun completely yourself, and also that you make it, assemble it and fire it. So you have to show to the world that from beginning to the end that you make something which is really your concept, your design, and that you're making it like this. Funny part though is that this, what you will see here, you don't see the part where it's actually shooting. When you look at this design, you see the part where the motors will be inserted, but on top of this part there will be this thing. This thing is actually shooting, and the reason I designed this on a separate design is because I also want to make, but I can't make it in time for this contest, I also want to make a turret gun. I think it's very nice. There are a lot of cats in my garden, sometimes also my dog is in the garden, and I think it's very nice to have something that can see for itself where a cat or a dog is walking and then shoot a Nerf that way, so the animals can play with it. And I think it's really fun to do something like that. So that's also a thing I'm going to make, and I'm going to make it from the same parts, and I want to have this this part so that you can disassemble it and you can make it on the turret gun. And then there will be a camera mounted, and that's also why I want a Arduino incorporated in the design. Also, let me tell you how I bring in the Nerf dart in the system. And because I wanted a mostly printed design, I'm going to show you in 123D design here how I created it. And well, basically it's a handlebar with inside here the trigger. The trigger will be held together with elastic bands, rubber bands, so it will always come back to the normal release state. And when you fire the gun, then this will go to the front. Here I have the part. I'll take a look how I can show you. Good. Here you can see that the height difference is being terminated by this thing that holds the things together. And then here you can see the part that pushes the Nerf dart, which is in the chamber here, and it pushes it all the way to the front of the barrel, and then you can shoot it. Look what John Doe said. You should make a smartphone adapter for the phone so you can use as a sight, and also seen adapters that connect to a scope for the phone. Yeah, that's possible, because I'm working with the Hero 3 Plus, the GoPro Hero 3 Plus, and this makes it possible to indeed use a phone as a scope or as a sight. But also you can connect a monitor to it. So I have some monitors as well here at hand. The funny thing is I run a video company, so I have a lot of great monitors here, and I can use those as well to use as a side. Now this is a very heavy one, but I also have very lightweight ones. So this is my design I've come up with, and when everything is printed I will assemble it. When it's assembled I will see that I made some mistakes, I think, and then I have to reprint and maybe make some things more smooth, or lubricate things, or well, I don't know what problems I'm going to run into. But in 2 weeks the competition closes, and then this gun has to be a working gun. So this is my project for the moment. Are there any questions from your side? And I'll also show you guys again what my printer is doing at this moment. I'll show it full screen. Will it be in PLA? Well, most of the parts will be in PLA. All the big parts are in PLA. In fact, some parts are not in PLA, and I'll show you. This, what I've printed here, is made in nylon, and also this trigger is made in nylon. And the reason is there has to be some strength on it before it works, and that makes that I think PLA won't be strong enough, but I don't know for sure. But I had some nylon here, so I said, well, why not print it in nylon and do it that way? Because I think nothing beats the strength of nylon. So, well, those parts are printed in nylon. How long will it take to print all the parts? Well, this is a 10-hour print on my printer, and you can see how quickly my printer prints, like here. So this is the speed my printer uses to print. And as you can see, this actually is an 8-hour print. And this is only, take it here, sorry for the heavy noises. This is this part, but it's only half the part. So this now is printing, and it's about an 8.5-hour print. And well, as you can see, it's a very long time to print. So all the parts together, I guess it will be 60-65 hours, something like that, to print. When you're printing, like me, on 60 millimeters per second, because my printer is now running 60 millimeters per second. PLA should be strong enough, but it might be too brittle. Well, yeah, I've had that problem as a problem really already. I am going to show you guys, but therefore I have to get myself apart. I have it here. So I have a lot of misprints, and I even at the moment thought my printer was defective, because what happened, this is the part that lays on the print bed, and I do a lot of PLA prints, and I never had a problem like this. But see what happens, this is not connected at all. I can move it all around. So as you can see, I can really lift it here, and I can get it off. So this was really strange, and I didn't know what the reason was. I also had another problem, and for that other problem, I don't have that part here. It's downstairs in the garage. But what I had was that my part was shifted mid-print, and it was shifted very, very strange on the x-axis, and well, I didn't know what was causing this. So I printed again, and again it shifted, and I have that part here where it again shifted. And what was happening was that the gun was printed like with a lot of support, and the print head was going this direction and banged against this braking part. So when this happened, the stepper motor wasn't strong enough to get the head more to the left, and it missed some steps. And at the moment this happens, the whole print shifts to the side. So I've had this happening 3 times, and that's when I decided to take this part and slice it in half pieces. So in fact, when you take a look at this part here, and I say, well, move it apart, move it to the side, then you see it's only the half part, and that's what I'm actually having here. Here in my hand I have this half part, so I sliced it in two, and then I printed both of them, and this gives me another advantage, because now I can use way less support material, because I can now print it like this, as you can see here in my printer, where it's printed on its side. When you bring up the print information window, it makes the audio echo only when that's on the screen. Okay, so take a look what happens. I'll bring up the print information, and then there is an echo, you say, which is strange. I don't know what can cause this echo, but I won't bring up this information. So I will stay here, and I won't bring up the information again. So only when that screen is being shown. And is it also if I bring in this camera on full screen? Is there a problem as well when this happens? Because it might be that it's this camera here. Maybe that now the echo is there as well. Okay, so I will quit using that camera then, because then that camera is causing the problem. So I won't use that camera again. Then the next question is, I saw something about ABS. Is your printer able to print ABS? Yeah, of course. I can print with this printer. It's a DaVinci Pro machine. It can print PLA and ABS via the official way. I also print nylon on it, and sometimes even flex material. But for the flex material you have to do a lot of things to get it to work, and it really isn't reliable to do so. But yeah, for PLA and for ABS, it's a great printer. I must say that if you take a look at wrong screen here. If you take a look at my printer now, then you see that on the bed there is blue painter's tape, and this blue painter's tape is great for some things, but it isn't for PLA. So I have more of those printers, and I'll show you when I get back on the screen here. I also often use Captain tape. Captain tape is this yellow tape, and when you use glue stick on it, and not every glue stick, but you have to use, for example, the brand Pelican, which is really good. Together with Captain tape, then you can print ABS, and you can also print nylon on it. Way easier is Build-Tack. I use that a lot, and Build-Tack is great for PLA and for ABS, but you can't print nylon on it. Some people say it must be possible if you put some glue stick on Build-Tack, but I don't have very good experience with it. So I won't advise Build-Tack when you're printing nylon. But for this print, well, it would be easy for me, and this printer has a camera inside. So for this print I use blue painter's tape, and well, this printer prints everything. There is also something I can show, maybe. I have to take a look how I'm going to show it. I have to grab this camera and see if I can lower it a little for you guys. Something like this. And But this is the camera that gives the audio a little bit of a problem. But just to show you shortly, here you can see I've mounted fence on my camera, and I also see that there is something wrong with the image, which is funny. So I've mounted some cooling fans on my camera, on my printer, and those cooling fans help me to cool the PLA down, so I can print with a little bit higher temperature. Normally I would print PLA in 205 degrees centigrade, and now I'm printing at 215 centigrade. And the reason I do this is then the bonding is a little bit better, and I cool it down very rapidly because there is a double cooling fan. And this helps me to get nicer prints, because if you see, where did I put it? Here. If you see how nice and smooth this print is, it's really very, very nice. So this happens when you print a little bit with a higher temperature, but you cool it down very rapidly. And this also works against this brittle PLA thing. See what other questions there are. Do you have a UPS for your printer? Not for this printer, no. For this printer it's normal on mains. Our mains power in Holland is very, very good. Only once in 3 or 4 years there is maybe a delay for 2 seconds, 3 seconds here in the place where I live. So I don't have a UPS for this printer. I do have a UPS for my my other room where some printers are, and there I do have a UPS system, because there is also my server and some other things that I use for my company. So there I do have a UPS, but to be honest, only one printer is having benefit of the UPS. All the other printers are not connected to that rail. Are there some other questions yet? Because I've shown you a lot already. By the way, this here is a nylon part. So this I've printed in nylon, and this goes on the trigger assembly like this. So well, I wanted to have as much parts as possible printed, because what I really think of this contest, it's a great way to have children explore 3D printing. I think that when a parent, a father or a mother, or maybe a teacher in school will print a gun like this in all the parts I have here. Sorry for the hard banging. In all the parts I have here, and then start assembling this gun with the kids, with the children, and then the assembly has to be tested, and there has to be some very basic electronics inside, because you only need to wire the motors to the battery. So it's very basic, but it's great for children to do so. So I really think that this is a very challenging thing for kids to make, and especially, for example, a trigger assembly like this. It's nice for children to see how, if this is the place where it's rotating, then this part is smaller than this part, so the movement here, which is only 2 centimeters, will be 6 centimeters here, and that will give you enough room to put a dart into the shooting assembly. So I think it's a great challenge for teachers, for parents, to have their children liking 3D printing. More questions. Do you use acetone to get better finish on the PLA? No, not on PLA. I do use a lot of acetone. Here I have it, and I have many of those bottles. I use acetone only on the ABS prints. Acetone won't work that good on PLA. I do, however, use some primer on PLA, but only if I'm going to paint it. And I sandpaper it, primer it, sandpaper it, primer it, and then it's so incredibly smooth. And also there is a video here on my channel in which I show how I sandpaper a bear, or boar you call it, on the inside. And there is a very easy way to make a roll like I have here, and that's what I showed in that video, where you have, like, I hope you guys can see it, there is a small opening here in the sandpaper, and there you have a piece of copper wire running through it. Then you can roll it like this, and then you can use the copper wire in your Dremel or other multi-rotor tool, and you can use it to bring it inside a barrel, and it will rotate with 5,000 rounds per second, so 5,000 RPM, and it will completely smoothen out the inside of a barrel. So this is a great way to sandpaper things. From the outside you just have to sandpaper it. I start with an 80 grit like this, and I go up all the way to, most of the times I use 800 grit as the maximum, and then I'm going to finish it with some spray, sandpaper it again, and finish it again with some spray. Look for another question. I love the design you come up with. I'm inspired to model something up. Not in time for the competition though. Well, the competition is only 2 weeks old, and this is what I have already, and there are another 2 weeks left. So in fact you could be able to create a thing like this and be able to print it in time for the competition. And I've lost 5 very valuable days, but I had to work, so I couldn't spend those 5 days on this design. Therefore I've only worked 10 days on how it is right now. So I think that if you like, give it a try, and try to join the competition, because it's a great competition. And to be honest, I'll show you, I don't get how they did it, but they did it. If you take a look here at the prices, I mean, oh my god, they have the grand prize, an Ultimaker 2 Plus a surprise bundle of 7 Ultimaker filaments. So the one who is going to win this, well, thumbs up, because, whoa, it's a great prize. Second prize, filler base kit, micro V6 hot end, Apollo ASA filament, Biofila filament, and the list goes on and on and on. Then there is a great third prize, best team design, most difficult to print and or assemble. To be honest, I make a gun which consists of a whole lot of parts, and I really hope I won't fit in that group of the most difficult to print and or assemble. And the reason why is that so many fathers, mothers and teachers could benefit from it to make something like this, which kids find really appealing, and create it with their children, that when you will fall in a group like most difficult to print and or assemble, then there is a real big risk of people not going to use your design just because they think, well, it's too difficult, and they won't try it. And I really hope that if I have made something and I'll show it to the world and I give you all the files, and you can do with it whatever you want, that people are going to use it to inspire those children and are going to use it to help people love 3D printing. And I think this whole competition is about that. For me, all the prizes are great, but even if I don't win anything, all the fun I have had with my children designing this and playing with it, and we started shooting Nerfs at each other, and we started trying with gas chamber propelling, with springs, I've had so much fun with my children that even if I don't win any prize, I've had my prize already. It's so much fun. So you can be in time, I think. And if you don't win anything, then at least you have shown the world what kind of design you make, and also you've given the world something to print with and something to play with. So let it be reason enough to join the competition. How many infill do you use on the parts, and how much filament will it take to make a gun? Well, good question. Very, very good question. As you can see here, on the parts that are only there for the length, I've only used 10% infill. So those parts are printed and are very lightweight. They really, this was 16 gram. So it's really lightweight. On the other hand, parts like this, where there will be some assembly on the inside, and well, this will take some strength. This is 40% infill, so I use a 40% infill here. And also there where my motor mounts are, I don't know if you can see it if I run this full screen. I have to find my mouse, because my mouse is running away. Don't know if you can see it, but this is, I guess this was 30% infill. So yeah, the infill will depend on what kind of part you are making. But for those big parts, you really don't need that much of infill. 10% is more than enough. The only thing you have to be sure of is that the top sides are really flat, and if you have a 10% infill and you print like this, and you're printing your top surface, then the first 2 layers, they won't be very smooth. So I've printed this in 3 layers top, 3 layers bottom, and even 4 layers around. Because, well, I think you need this. And I work with Simplified 3D to slice my parts. If I would have sliced this on, for example, XYZware for Pro, for the DaVinci machine which it comes with, I don't think I would have been able to slice it this nice. I think I'll try a vacuum style launcher. Well, yeah, that's also something I've been thinking of. The thing is that when you, for example, when you have a blowhole, like here, I don't know if you can see it, and you will vacuum the part, and then the Nerf will come in and will go to that part, then there is a point where the air is going another direction as the Nerf, because you want the Nerf to escape from the barrel, while the vacuum pump is still working. And the thing with that is that the moment it comes around that opening where the vacuum goes the other direction than the Nerf goes, then there is so much force on the Nerf, for what I've tried, that it won't work, because this Nerf only weighs 0.8 grams. It's only 0.8 grams. It's really not that much. I'll show you here. This was a Nerf that was shot to pieces when I used the gas propulsion on it. There is only a very small part of plastic inside to make the Nerf a little bit front heavy. So in fact, I don't think that the vacuum way will work, as also this barrel didn't work, just because the moment the Nerf is going to leave that barrel, there was too much resistance. Are there still other questions while we are looking at my printer? Any other questions I can answer? And if not, then I think I've had a very nice live stream and I will maybe quit this live stream. Could you design... could you do raffling if you wanted to, and would it work on a Nerf gun? I don't guess it would work. And the reason is, if you do so, then the Nerf would spin around. But the force you need to do so uses energy. And the problem with a Nerf is that because it's so lightweight, you can't store any energy in it. With less than a gram of weight, the energy amount you can store in this is really not so much. So the moment you shoot it and it also has to spin, then a part of your energy is going to be in that tumbling motion. And of course it would benefit from that, because any bullet, when it starts spinning, it will fly like this and it will be more stable. But the other thing is that it will absorb some energy, and there is only so little. So I don't think it will really work. But it would be very easy to design, yes. You can even do so while sandpapering your bore. Because when you sandpaper your bore in a stroke every time, that goes from one way to the other, then there is already this riffling in your bore. So yes, it would be possible, but I don't think it would help you. You won't benefit from it. Any other questions while we are looking at the printer? No other questions. Well, in that case, I'm going to thank you all. And it's now 1:15 in the night, and this means that that I'm allowed to be tired. So I will quit this live stream, and well, in about a week I have to go to Germany, and I have to be there for a week to a very large venue where I have to be. So I have only one more week to spend on this Nerf gun. So in about a week my files will be online, and I hope you all give your opinions on them. So thanks for watching. If you're not already subscribed, please subscribe. Hit the like button if you like this stream. Give your comments on it, and thanks for watching. See you guys another time. Bye bye.